All right, so let's start it. Let's give everybody a couple more minutes to join. Okay, let's minimize this. Okay, and let me get the share my screen. All right, can everybody see my screen?
Yeah.
Yes.
Bring up my chat. Chat. Minimize this. And minimize that. All right, so let's take a look at the syllabus, see where we are, where we've been, and where we're going. So over the weekend, you worked on the midterm exam, and it was available from Friday all the way to yesterday, right? Last night. It looks like a few of you had a couple of issues with a couple of the questions. Make sure to take a screenshot of the question that you thought you might have had some issues, and send a private post on Meta, and the TS and myself are going to take a look at it, see if it's something that was particular to you, or if it's something more for all the students, and then we can regrade those questions for everyone. I will be making the answers available a little later. There's still a few folks that are taking the exam, so let me wait on that, and then I'll make it available so that you can take a look at it and let me know if you have any issues with the exam. So this last week there was no assignment, and because you were preparing for the midterm, and so today we're going to get started with the next assignment. And we're going to go back to the same cadence as we've been doing for the last month or so, 2 months that we've been together, right? Where there's going to be an assignment every week. So the next couple of assignments are somewhat special in that they should start giving you, together with what we've looked at for the rest of up to this point in the whole semester. These two next assignments should get you going and preparing you to create an application, right? That you should be able to use this as a setup, as an initial setup for an environment that will allow you to create some kind of application, right? And that you should be able to use for your final project. Okay. Today we're going to be learning we're going to practice, how to connect to a database, right, using a programming language, and in particular, we're going to be using Java. We could have chosen any other language, but specifically, we're going to take a look at Java. We already practiced last week connecting to the database using Jdbc, and because basically we do need a way of extracting data from a database and representing it in some kind of user interface so that folks could interact with that data, right? Usually when folks interact with the database through an application, they're not going to use Workbench, right? They're not going to be at a console, looking at data directly on tables and joining and things like that. Instead, we need to create some data model, some UI representation that allows users to see their data, create new data, update existing data, delete data, right? Find and retrieve and query data, and then represent it in any way you want to represent it, either as a table or cards or forms that people are filling out, whatever your user interface ends up being, right? Basically those are going to be all those commands and buttons and clicks and keystrokes and moving of the mouse. That needs to be converted into actual, query commands, right? That insert or update or delete or select and all those commands that we've been using. So we need to be able to issue all those commands from some programming language, right? We've chosen Java. We could have chosen any other language. We're going to be introducing also technology today called ORM, Object Relational Mapping, which is going to be the next step. It's the next evolutionary step in interacting with the database, right? We looked at how to do it with Jdbc. Jdbc is a very low-level programming interface to interact with a relational database. It's the most how do you say versatile and allows you to do most of what you would possibly do with from Java to a relational database. It's the closest that you can be in connected to a relational database, but without actually executing inside of a relational database, right? For that, you would use store procedures or functions or triggers, whatnot, right? So here we're outside of the database, but we still are able to connect to it. So we saw Jdbc last week. This assignment is gonna first ask you to play around with Jdbc. And it's gonna ask you to implement a data access object using Jdbc. And then it's going to ask you to do the same exact thing, but using the new technology that we're going to introduce today, right, which is ORM, right, Object Relational Mapping, right? And in particular, we're going to be using Java's implementation of an ORM, right? Which is called Jpa Java Persistence Api, right? And now there's tons of ORMs out there. Java has a few ORMs. JPA is kind of like the standard object relational mapping framework, and it's based on a very popular framework that came out a while back, and it's still very popular, called Hibernate. But there's many other vendors out there that compete in this space, right? You have Toplink, EJB, Eclipse Link, Kodo, JDO, and any language or framework that you might use, whether it's Python or .NET or PHP, right? Each one will have its own ORM implementation. There'll probably be several that compete, right, within that framework. And I encourage you to explore these ORMs. And for the project, you're free to use any language you prefer, right? And any ORM framework or whatever user interface you prefer to use. If it's if you prefer to do a phone application or desktop application or web application. It's up to you, right? Whatever database you want to use. We're covering MySQL, but if you prefer to use Postgres, or if you prefer to use Firebase, or if you prefer to use any other database for the project, you're free to do whatever you want, right? For the actual implementation of the code of the application, again, I'm covering Java. But if you feel more comfortable with Python or .NET or PHP or whatever other language you prefer, feel free to use that as well. Many of the same concepts that we are covering today and for the next several weeks are equally applicable in any other framework that you choose, any other database that you choose. Obviously, each one will have its own little quirks, its own little syntax. Might be slightly different, but conceptually, right, they're all doing the same thing. Okay, and that's I think that's what you end up learning after decades of an industry, is that there's an evolution and there's an iteration of rehashing of old ideas, right? Just presented for solving new problems, same ideas but new problems applied to new problems. So we're going to focus today on JPA, and as one of many object relational mapping frameworks, and they're all trying to do the same thing. Right? If you remember when we played around with Jdbc last week, right? We saw that talking to a database can be fairly complex, right? You need to create a connection, right? You need to instantiate the driver. You need to log in, right? You need to compile a SQL command. You need to execute that SQL command. You need to then process the results from that SQL command, iterate over it, and then parse each one of the values from the columns, instantiate an object, right? Populate that object, maybe populate an array of those objects, right? So there's a lot of things that are happening. And so what object relational mapping tools, what they try to do is says, well, how can we smooth this out? I mean, it's way too many things happening, right? And we'll see today how these ORMs do this, right? We'll first do it with Jdbc, right? Using all the nitty-gritty details of how to do this in Jdbc and connecting to a database, blah, 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 right? And then we'll show you how to do the same exact thing, but using an ORM. And you'll, my hope is that you realize how much easier and useful it is to use an ORM, okay? Obviously, there's still a place for Jdbc and these libraries that are low-level libraries, obviously, right? But depending what you're implementing, if you're doing something very generic or if you're doing something very specific, right, you might choose either an ORM for the very generic or Jdbc for something very specific. Okay, so let's get into the assignment, and that's gonna open up on and how we can implement both using Jdbc and ORM. We'll contrast one and the other. It'll give us a chance to practice. And my hope is that you can use this framework, that this project that we're giving you as a beginning, right? As the beginning of or setting up for getting started on working on your project. Okay. Let me see. There's a question on the chat. Yeah, there's nothing due today, right? There was no assignment last week. Right, and the intention was to give you a chance to prepare for the midterm, right? But now we are going to get back into cadence of one assignment every week. Okay. All right. So yeah. So this first assignment, the ORM assignment, you might find, depending on your background and your whether you've built applications before, if this is a more introductory course for you. ORMs could be considered to have a fairly advanced topic and have a somewhat of a steep learning curve, right? So for this assignment, we're going to walk you through the whole thing. Okay, we're going to tell you exactly what to do. Copy this here, paste it here, run it. Verify that it works. Right? We're not going to ask you to do anything on your own. Okay, you're welcome to explore and actually go beyond. Right, but it's not going to be required. Right, we'd give you a couple of examples on what you might want to do on your own to practice it. Right, but it's not required. I encourage you to do it because I think it'll help you tremendously going forward, working for the upcoming project. Right, same thing for the next assignment that we'll introduce next week. Right, this is web-driven applications. We're going to introduce a little bit of React. Just because you need some kind of user interface to interact with your application. You're free to use other user interface solutions, right? If you feel comfortable with building phone applications, go for it. If you build a desktop applications, you go for it. So you feel free to use other user interface solutions. I'm gonna cover some. Enough of web-driven applications, data-driven web applications to interact with the database using web. Okay, but by no means do you need to go with that solution. I'm going to give it to you so that you can perhaps use it to build your own project, your own ideas. Okay, so these two assignments, 7 and 8, are going to be very, very handhold. Right? We're going to handhold you through the whole thing, exactly what to do, right? And then you can feel free to expand and learn more on your own. Okay. All right, so let's go for it. Let's see. There's a question on the chat. Speaking of the project, would it be possible for the project requirements to be released? Yes, we will talk about the project in detail this upcoming this Friday. We'll talk about it and all the requirements, and we'll see how what we've used so far will be all the technology that we've presented so far, how that can be used for the project. Okay. All right, excellent. Let's get to it. Let's see the assignment. Okay, so here's assignment. All right. Okay, so the assignment is right here. All right, so to get started, we're going to still be using the same schema, the same database that we've been using for the last 2 months. You can download it again from here if you want to start from scratch, or you can just use the database that you've used for the previous assignments. You can use that. We're also going to provide you with code to get you started, right? So we're not going to ask you to create everything from scratch, right? So we're going to give you some code to get you going, so if you navigate here, you can download this code 2 different ways, right? You can either download a zip file, and this will contain all the code that you need. Right? You unzip the file, it'll create a folder. In that folder, you'll have the whole project which you can run out of the box. Okay. Or if you are familiar with Git, right, you can clone this project. Right. So I'm going to use Git. Right. If if you're a software engineer or you're aspiring to be a software engineer, right, I strongly advise you to get comfortable and familiar with Git. If you don't already have Git, I would strongly encourage you to download, install a Git client. If you're using Mac OS, chances are that you already have Git installed on your operating system. On Windows, you'll need to perhaps download and install a Git client. There's some really nice ones. Source tree. If you look for a source tree, that's a really nice free Git for Mac and Windows. It's very easy to use. I really strongly encourage you to get started with Git if you haven't already. Okay, so I copied here the URL for my Git. I'm going to go to my terminal, and let's see. Okay, so I'm going to create a directory for this section. So I'm going to, let's see. I'm going to make a directory for section 4. I'm going to go in there, and I'm going to clone down that project. So I'm going to say git clone paste. So it's going to copy that down, and it creates a directory for us. There it is, right? Now, if you use a zip file, it will create the same exact folder. Okay, and so we're going to go in there, and so we're going to do all our work in this folder, right? So I'm going to. I also encourage you to use a full-blown IDE. Okay, I mean you could complete this assignment with just a text editor, right? But it'll make it much easier, right? If you are using some kind of integrated development environment, right? Preferably, I'm biased towards IntelliJ Ultimate. It's free for faculty and students, right? If you register with your NEU EDU account, right? Then you get a free license at least for a year, and then you can renew it and indefinitely. So definitely get a hold of an IDE. I strongly encourage you to try out IntelliJ Ultimate if you don't already have it, or if you prefer Eclipse, that's another IDE that you can try out, or you can use VS Code, right? I think Ultimate is the one that best integrates with Java and all the tools that we're going to be using. So I strongly encourage you to go with the IntelliJ Ultimate. That's what I'm going to be covering. So it might be slightly different, these instructions if you're using some other IDE. But the TAs and myself are going to help you out all the way. Right? Obviously, if you're using IntelliJ, it will be so much easier to support you. Okay. So anyway, so what we're trying to do, right, is that we have this database, right? We have all these tables, and we need to transfer the data that is in the database, right? And we're going to transfer at least part of it. We need to transfer it over to the application, so that the application can then, once it has that data, represent it in some user interface, right? So that the user can interact with it, so that they can create new records, delete records, update records, right, from the user interface, right? So we're going to keep it simple. we're going to just interact with this simple table that already exists in the database, right? It's the same table that we've been using for the last couple of months, right? That has the username, password, first name, last name, profile, created, blah, 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 right? So it has all these fields, all right? So the intention is that that's how the data is represented in the relational database. We need to map all that data, right, in a data structure that is common in object-oriented programming languages, such as Python, object-oriented language Python, object-oriented Java, C#, or any other object-oriented language. Typically, the way we describe data in our object-oriented programming languages is through the use of classes, right? Classes will have all sorts of fields and data types and arrays and inheritance. It has all sorts of things, right? And our job is to map data that has been stored for long-term storage in a relational database. We need to map it into this class representation, right? Object instances in object-oriented languages, and knowing that there are some things that are different in both worlds, right? There are very distinct worlds, right, with their own conventions. And we need to be aware of these conventions. For instance, in object-oriented programming languages, it's common that classes are nouns, they're singular, right, and they're capitalized, right? Whereas in a relational database, they're also nouns, right, but usually they're all lowercase and they're plural. Also, in a relational database, right, the identifiers are usually all lowercase, right, or it's case insensitive. It doesn't really care about the case, and so that's why we rely on underscores to separate words, right? So that's the naming convention in relational databases. Whereas in object-oriented programming, right, usually the convention is that it is case sensitive, right, and the keywords are often, we camel case it, where we capitalize the first letter of each word, right? So we have to understand the differences and what's different, what's the same between these two worlds. What can we map easily between the two, right? So we've done this already. Last week we demonstrated using Jdbc, right, where we retrieved records from the database. We iterated over the rows, right? We parsed the columns, the data from the columns, and then we instantiated objects, and we populated each one of the fields of those objects. We did this last week, right? We're going to do it again here, and so we need to be aware of what's the same and what's not the same between the two. Okay. So in the project that we just cloned, right? Let's open it up, and we'll show you what we give you. Right, so let's go to Januzzi, and we'll go to NEU, and 2021 Spring 3200 Section 4, and this is the project. All right, let's open that up. So we already have the database. You already have the table, right? We're going to give you this class already implemented, right? So you don't have to implement the class, okay? And so our job is to read from the database all those records that are in the database, and each one of the records, convert them into object instances of this class, right? And we're going to do it first with Jdbc, right? And then we're going to do it again using JPA, okay? And we're going to contrast and see what's the same, what's different. Why would you use one, or why would you use the other? Okay. Okay. All right. Excellent. So we give you that. We also give you the beginnings of a data access objects implemented with Jdbc, right? Which is going to look very similar to what we played around with last week, right? It's implemented under the DAO directory here. There it is. Okay, so we have a few things here. We have several constants that allow us to configure, right, where are we connecting to? Where we're connecting to a MySQL database, right, that is running locally, connected to a schema here. Notice that I'm using your schema So here you're expected to use your schema. So I don't know, DB design, right? Also your username. You're expected to use, I don't know, I'm using CS3200 as my username and password. You might be using a different username and password. Please use yours and configure this so that your Jdbc driver will be able to log in to this database, right? So they can start communicating with the relational database, right? So we give you that. We also give you a couple of functions that is going to allow us to instantiate the driver manager and also grab a connection to the database. Connect to the database, log in, and so we encapsulated that in this set of functions, right? So that you don't have to do that over and over in each one of the methods whenever you're trying to connect to a database. So it's conveniently in here. Okay. So in get connection. Here's get connection. Notice that it does the class.for name for you, right? So it retrieves the correct driver. It grabs the connection from connects to a database using the URL, username, and password. Okay. But the difference here is that we also are giving you the closed connection. So last time we got lazy, right? I believe we connected to the database. We did a couple things with the database and we never closed the connection. Now, if it's just you with your own database, this might not be an issue, right? The database has a limited number of connections that it can allow multiple clients to connect to the database simultaneously. If it's just you, it's not a big deal. These connections they'll time out after a while and they close them, so auto close, right? But if you are working in a team and you're all using the same database, you have to be careful. So let's see this. I think there's a question in the chat. Why is the ID in user an integer, so a primitive type? Yeah, I prefer to work with the class integer. The student is asking about me. I'm using integer as opposed to int. You could use int here as well, and it would work just fine. I prefer to use integer because you can compare it against null, right? As opposed to comparing against 0 or -1. Null means I don't have a value, right? It's not valid. It's an easier way of checking to see if there's some error, and for debugging as well, it's easier to work with full classes as opposed to primitive data types. Yeah, good question. Where was I? Oh yeah, closing connections. So if you're working in a team, if you're all by yourself, then it really doesn't matter whether you close the connection, even though it's a good practice to close the connections once you're done. But if you're in a team, right, and you've been working with this several times, you've been hitting the database, several times, 20 times. It could be that maybe your colleague is also trying to connect to a database, and all of a sudden he shouts and moans and says, "Oh, I can't connect. There's no more connections." And they start complaining, who's not closing their connections? Well, you don't want to be that person, right? In a team, right? And be embarrassed that you haven't been closing your connection. So make sure that once you're done with the connection, the network, just close it and you're done, okay? So we're going to be using the we're going to be implementing these CRUD operations, right? These are the most common types of operations that we're going to be interacting with the database, right? You need to be able to create a piece of data, retrieve a piece of data, update it, or delete it. Right? So all the CRUD, create, read, update, and delete, right? So we're gonna give you the source code for it, right? So we first give you the placeholders. So these are we give you the placeholders for the methods, right? And we ask you to actually implement them, right? But we give you the code. So you're not gonna be doing this on your own. We're going to handhold you all the way through. Okay, these next two assignments, a lot of hand-holding, right? And the hope is that you practice this on your own so that you can then go on and maybe use this as a start of your project. Okay. Okay, so we're going to implement create user. So create user. Find all users. These are all the CRUD operations. They're all going to be using these SQL queries here. See that? These are strings for each one of the operations. Okay, we have create user, find all users, find user by ID, delete, and update. Okay, and update. And so each one of these, right? Each one of these functions are going to be using those strings, and they're going to be configuring these question marks. See these question marks? These question marks are placeholders, right? They're placeholders for actual values that we're going to inject in there. Okay. Now the question mark is it's a special character here in Jdbc. It's a standard character for placeholder, right? That we're going to dynamically inject data in there to come up and parse and compile the actual SQL command that's going to go out to the server for execution, right? And we'll talk about that in a minute, right? Why is it question mark as opposed to something else, right? So let's get started. Let's implement our very first command. The database we already have. I'm actually using a database called Your Schema, and I actually have a username that's called Your Username and Your Password. So I'm actually logging in as using the default configuration of the source code that I give you here. Okay, so I can test it. I can test it locally. And I already have a users table down here. See that? There it is, which has some data already. It has a couple of users in there. I'm going to blow away these users so we start off from scratch. So I'm going to just say delete. Right. I'm going to assume that this is a brand new database. No records, no prior records. Okay, there it is. So there's nothing there now. Okay, it's empty. Perfect. Okay. So create user, right? So create user is going to use the create user string, which has an insert, right? Has insert into users values, blah blah blah, right? And it's implemented here, right? So if I go a little further up, there's my create user, right? So insert user into values, null, question mark, yada yada, comma null null, right? So basically, this is inserting into this here, right? Into the first is ID, so null for the ID, then username, password, first and last. So username, password, first name, last, and then the profile, and then nothing for the created and nothing for the updated. Okay, null and null. Okay, so we need to populate this. How are we going to do that? Let's see. Let's look at the code that we give you. Right. So the implementation is right here. I'm just going to copy the implementation verbatim, and I'm going to paste it inside of my create user. There it is. So I'm just going to paste it in here. Let's go over this code. All right. So the code is fairly simple. So the first thing that we do is we grab a connection. So that's going to use what? Is going to do the driver, right? It's going to use the driver manage to get the connection. It's going to log in with a username and password, and it's going to return for you a connection. Oops. Right? All right. So once I have the connection, it's going to say connection dot prepare statement. Prepare statement. What's all that about, right? Last week we saw create statement. We didn't see prepared statement. What's that all about, right? And notice that it's returning the statement object, right? And we're passing this string. The string is the ones that has all these question marks, right? But look at the value. Look at the data type of statement. Statement is actually a variable of type prepared statement, as opposed to just plain old statement, right? At the end of last week, we talked about statements, right? And the connection being able to create a statement from a SQL string. But this one is prepared statement. So what's the difference between the two? Well, this one is much, much better than using plain old statements, okay? So one of the great things about prepared statements as opposed to just plain old statements is that these placeholders, we're going to be able to populate these placeholders using this syntax here, right? Notice we're saying statement. I'm going to set the string for the first placeholder, so meaning the first question mark, that first question mark, I'm setting it to be username. See that? User.getUsername, right? I think there's a question in the chat. Where is the prepared statement class coming from? Is it from the driver class? So prepared statement is, if you remember, right, everything is inside of the SQL. Everything's inside of SQL, and prepared statement is a sibling of statement. Okay, remember that the three interfaces that we're mostly interested in is the connection, the statement, and the result set, right, in Jdbc, right? The connection establishes a connection to the database. Statement allows you to execute SQL statements, and then result set allows you to process the results from the database, right? So that statement is the one we're talking about, right? That statement can be either the statement that we looked at last week, or this brand new prepared statement, right, which is a sibling to the statement. It's just a better statement, right? It's a better statement, okay? And let me tell you why is it better. Let me tell you why it's better. So for one, it allows you to use this API to populate each one of the placeholders, right? So the first question mark, the second question mark, the third, the fourth, the fifth, right? Which are here, right? The first, the second, the third, the fourth, the fifth. So we're setting strings there. See that? As opposed to what we did last week, right? What we did last week was that we were concatenating strings. Remember that, right? Well, concatenating strings is very dangerous, right? It's very dangerous. It opens us up for a vulnerability, right? Called SQL injection, SQL injection. Okay, right? What happens is SQL injections is about, where do these values come from? So these values, these values, this username, this password, first name, who's typing those? Who's providing those values? Well, they're human beings, right? That are filling out a form, some kind of form, right? Like a login form or like a registration form. So they're typing at the form text, and for the most part, 99.99% of the time, these are, innocent folks who are typing their actual first name, their actual last name, username, and password. But there's always going to be some malicious folks who, instead of typing, actual data, actual good data representing real data, they're going to be putting in there some code, SQL code, that if we put it part of this and we concatenate it with our strings, right, they're going to be able to control our database from a form that they're filling out, right? And they're going to be able to do things such as, maybe drop an entire table, or, have the database return all sorts of data that they should not be able to access, right? Or God forbid, they can access accounts that then they can log in as administrators and take control over our entire infrastructure, right? Let's see, there's a question on the chat. Or if your surname is null. Yeah, sure. Yep. So prepared statements allows us to guard ourselves from malicious attack, right? From folks that are trying to insert data, right? That is bad data that could destroy our database. Okay. So what prepared statement does is that it looks at the data that you give it, right? It makes sure that it doesn't have any special characters. It doesn't have anything malicious. We say that it sanitizes the data before it actually tries to process it, right, and put it in the database. Okay, so for instance, it verifies that it's the correct type, right? That if we're looking for an integer, it's actually an integer. If we're asking for a date, it's an actual date. So I think one of our users, one of our students, is sharing a famous XKCD. They're sharing a famous XKCD joke about it. Okay, here's a very famous joke that XKCD came up with to illustrate what could go wrong in for SQL injection, right? So here's someone at the school that calls a mom, and we're all worried, and says, "Hi, this is your son's school. We're having some computer trouble." And the mother responds, "Oh dear, did he break something?" Meaning her son. And she says, "Well, in a way." And the school says, "Did you really name your son Robert?" Close quote, close parentheses, semicolon, drop table student, semicolon, dash dash. Okay, meaning somebody was literally typing this out of form, right? And they took that Robert drop table yada yada dash 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 dash, meaning comment out the rest of the right, comment out the rest of the command, ignore the rest of the command, meaning drop the entire table's students. All right, and so did you really call this your name? I mean, do you name your son this way? And says, "Oh yeah, little Bobby Tables we call him." And so the school says, "Well, we've lost this year's student record. I hope you're happy." And the mom says, "Well, I hope you learned something, right? You learned to sanitize your database inputs." Okay. So anyway, so we don't want to be, right? We want to make sure that we don't, we're not vulnerable. So prepared statements, save us from this, right? Yeah, so prepared statements defend us from this kind of attack, right? So yeah, so that's a good thing, right? So we prepare the statement, and then we just execute the statement. In this case, we are inserting, right? And then we close the connection, and then return how many inserted rows there are. Okay. All right. So let's try it out. Let's practice this. Now that we've done that, let's go into our main code, and let's run this. Right. So we can let's copy here. We're going to create an instance of the Jdbc. There it is. And then we're going to create 3 objects, right? Adam, Thomas, and Catherine, right? Each one with their own first name, last name, username, password, and profile picture, right? And then we're going to use our brand new create user, Adam, Thomas, and Catherine. Let's paste that in there. Now we can run it. You can run it from here in IntelliJ, or if you're using a different IDE, probably you'll have something where you can right-click on the class and then just run it right from here. So either way, I'm going to run that. So that should insert 3 records into our database. And if we go to our database and we refresh, right, notice that indeed we have those 3 new records in there: Adam, Thomas, and Catherine. Okay, awesome, that worked. So let's move on. Let's move on. How about now that we've inserted some data into the database, let's retrieve that data, right? Let's retrieve that data. So in the find all users, right? So we have find all users in here. There it is, find all users. And we're going to do the work here. So we're just going to copy the content, and let's review the content here. So let's copy and let's paste that in here. And so let's see. We're going to pretty much do the same thing, right? We're going to grab a connection, right? We're going to prepare our find all users. So find all users is pretty trivial, right? It's just select star from users. Okay. And then we're going to execute the query. There's nothing to configure. There's no setting of any strings, right? Because we have no parameters. So it's a blind execute the query. We grab the result set. We iterate over the result set. We instantiate each one of our users. Add, right? We parse each one of the fields, the columns, right? First name, last name, username, password, and so on and so forth. And we use it to populate our user object. We add it to an array, and then we close the connection, and then we return the list of users, right? To test this, we can we can use it and then iterate over each one of them, and then print out maybe the username, right? So let's go back to our main. I'm going to comment out our create because I don't want to insert the same users again, right? So I'm just going to retrieve all the users, and then I'm going to iterate over them, displaying the username, right? So I'm going to run that again. And hopefully this time it will just print out, Adam, Tom, and Kathy. There we are, right? We had all 3 users. Okay, let's see. It looks like there's a question on the chat. What is the column label and why is it rendered in that way in the IDE? The column label. Column label. Oh, column label. Yeah, no, that's my IDE. The function getString has a parameter called column label, right? And what it's doing here, it's just nothing. It's just a space. It's really nothing. It's just for documentation, giving me a hint that this getString function takes this variable as an argument, right? So that if you go into getString, the implementation, right? Notice that it has a parameter called column label. See that? And my IDE is grabbing that, right? And it's displaying it for me to give me a hint of what I should pass in as an argument, right? Again, that's a nice thing that the IDE just gives you, right? It's just for documentation. All right, so we were able to retrieve it, right? Notice that indeed we came back with the users run. Wait, we ran it, right? Where do we run it? Run, right? It displays Adams, Thomas, and Kathy. Perfect, excellent. Let's keep going. I'm not going to do user by ID. You can do that on your own. How about delete a user? Let's delete a user. And so delete user, I'm just going to copy the code. And I'm going to paste it in here for deleting. Let's see, we have delete. I'm just going to paste it in here. And same thing, right? We grab the connection. We prepared our statement, delete user. Now, delete user does have an argument, does have a question mark, which is the ID of the user that we are going to delete. Right, so we have to populate that. So there it is. We're sending the integer of that first question mark. It's 1, not 0. Like most other things in Java, right? In Java, most everything indices are usually starting at 0. In SQL or SQL or Jdbc, parameters start at 1, not 0. Careful with that. I'm setting it to the user ID. We execute the update, which is deleting, and we close the connection. So let's try it out. And to try it out, we're going to delete our first user, which is Adams, I believe. So let's go here. Let's not retrieve all the users. Oh, actually, no. Right here, we're going to remove the first user, and then we're going to display all the users and verify that that user that we deleted is no longer there. Right? So we used to have 3 users. Right? If we retrieve, notice that we have 3 users in there. So the user ID is that we're retrieving is 16, right? So let's change this to be 16 here, right? If the ID that I ask you to use in the documentation, if that one doesn't work, feel free to use a different ID, right? Because I mean, again, I don't know your database. So use the ID that works for you. So I'm removing Adam, which is number 16. Let's run that. So now I should only end up with 2 records as opposed to 3. So it comes back with Thomas and Kathy. And we can verify Adams is no longer there. Refresh, notice that it's indeed no longer there. Perfect. Finally, let's try it out with updating a user. And updating a user, I'm going to implement it by grabbing this and copying into our update user. So there's our update user. Let's paste it in there. Paste it in there. So basically what it's doing is, again, grabbing a connection, right? Preparing our statement. Now our statement for updating a user is, right, it's changing the first name, the last name, the username, the password, right? And then we pass in the ID of the user that we want to update, right? So we need to configure all that, right? And so we're going to set, for the first, it'll be the first name, last name. Ooh, I think this is wrong. This is supposed to be, I think this is supposed to be username. And this is supposed to be password. Get password. Okay, let me fix that in here. So this is supposed to be username and password. There we go. Okay, so let's try it out. And let me make sure that the first one is your first name, right? Let's see. Yes, first name, last name, it's in the correct order. Okay. Okay. All right, let's try it out. And the last one is indeed the user ID. Perfect. Let's update Tom. Let's update Tom. We're going to create a brand new object, Tom. Okay, and we're going to update it and then print out all the users. Okay, so we're not going to delete anyone anymore. We're going to update Tom. Tom's ID is what? Tom's ID is actually 17. So let's copy that. Oops. Ah. Oh, no. Let me revert that. Sorry. Revert. Okay. So it's 17. So let's change this to be 17 here. 17. Save that. And so we're going to change the first name to be Tom. So instead of Thomas, it'll be Tom. And instead of username Thomas, we'll change it to just plain old Tom. And the password, it used to be polymath, and we'll change it to know-it-all. Okay. All right, let's see. Let's run it. Let's save. Let's run. And we'll display the username. Hopefully, it'll say Tom. There we go, Tom. We can verify that. We can refresh this. And indeed, notice that it is Tom, know-it-all, right? And we're able to change the first name as well, the password, and the username. Perfect. Excellent. So it does work. All right. Excellent. So we've demonstrated that we can use Jdbc to communicate with the database and implement all sorts of updates, deletes, inserts, right? We can pretty much do anything we want to communicate with that particular table, okay? Now, if you implement another DAO, right? If you implement enough DAOs like I have, right? And you've been at it for several decades like I have, you'll start finding that a lot of these are all the same, right? They're very, very similar to each other, right? And you find that there's a pattern. And so many other people as well identify that there's a pattern, right? These are almost the same. The only difference is that, right? The only difference is that if you're going to create a user, right? Or if the only difference if you want to create a blog, then you would have to replace this with blog. You have to have a SQL that is specific for the blog, right? You're going to have the fields that are specific for the blog, right? You're going to have the update, close the connection. So the DAO for any other data type is going to look almost identical, but right, the data types are going to be different, right? The fields are going to be different. The data types are going to be different. Okay, and for any of these, right? Same thing for find all users, right? It's going to have a parameter for the find all users. It's going to be a different table. It's going to be a different object. It's going to be a different set of fields, right? If we could possibly parameterize that, right? If we could create a generic DAO, right, and we could parameterize it, we wouldn't have to write a DAO ever again, right? We could just parameterize it. And it turns out that the user class has enough information, right? It has enough meta information that we could have a generic DAO, pass it user as a parameter, and says, hey, write me a DAO that can automatically, right, read or write data from this object user into a table users, right? Or read records from a users table and automatically convert them into fields, right? And populate instances of this, right? So I don't want to have to write these DAOs anymore, right? I'm going to burden you with writing one DAO at least once, right? At least one DAO in your life. But then once you learned how to use ORMs, right? ORMs implement this generic DAO, right? That you can parameterize and say, hey, write for me a DAO. I don't want to write it. Do all the SQL statements for me. Even all the SQLs, right? All these SQL statements can also be generalized, right? Users can be derived from the class user, right? all these fields, how many fields I have here, that can derive from the class users, because I have a list of all the fields. Right here too, all these fields can be derived from the fields that are in the user class. Right, so all of this could be derived automatically, right, without me having to write a single line of code. Right, and that's exactly what ORMs do for us. Right, they do all the boilerplate stuff, right, so that we don't have to write any of this. Right, so let's see how we do that. How do we do that? Okay, so it all starts with coming to our user class, and annotating it, or letting the infrastructure know of our intention to map this user class to a table on the database, right? And we have to provide 2 annotations, just 2 things, and we're done. Okay, we need to first say that this is an entity. Okay, notice that entity is an interface inside of the JavaX persistence package, right? That is where our ORM implementation is, right? Inside of the JavaX persistence package. Okay, so entity, what it means is that this class, right, is going to be mapped to a relational database, a relational table, right, that lives somewhere. Okay. Right, we need to determine how to find that database in a minute. All right, we'll do that in a second. And the other thing that we need to tell it is that the primary key, right? Those 2 things are required. They're required and they are enough, right? If we do that, right, this will look for a table, will automatically look for a table called user with a primary key ID called ID. Right, now that's not exactly what we want, though, right? The table is not called user, right? It's deriving the name of the table from the class, right? And because of the naming conventions that in SQL typically we use plural nouns, and that in Java we use singular nouns, right? There's a little mismatch there, right? So we're going to fix that by overriding some of the default behavior, right? Some of the default behavior, right? So let's override the fact that the table that we want is not called user, but users instead, plural. So the way we do that is that we add an additional annotation. We say that the table that we want you to use is not the default user, but instead the name is users. Okay, right, so we're overriding some of the behavior. Okay. The other thing that we're going to override is that by default, the value of this primary key, we are responsible for creating those primary keys, right? The values of those primary keys, right? And says, okay, so we have to come up with unique identifiers for those IDs, right? But we're lazy, right? And we know that we have already configured our users table to use auto increment. Right, so we've already delegated this to the relational database. We don't want to be bothered with that. Okay, let's see. There's a question on the chat. I haven't seen the @ notation before. Can you please explain again what it does? Sure. So annotations, right, in Java and in many other languages, you see that popping up everywhere. Okay, is a style of programming called aspect-oriented programming. Aspect-oriented programming, and just like there's object-oriented programming, there's component-based programming, right? All these are ideas that software engineers have evolved over time. Some ideas on how to make things easier, right? So basically, what happens is that there is a class called entity. There's a class called entity. There's a table. There's a class called table that encapsulates all sorts of behaviors in there. And those classes and those behaviors can then be applied to other classes. Okay, just like we have extends that allows you to inherit, right, behaviors from other classes, or implements, right, that allows you to say, oh, some class has these functions, and I'm going to provide the implementations of those functions. So all these are object-oriented ideas, right? Well, there's aspect-oriented ideas that says, well, there's this class called entity that's going to do all sorts of crazy things, right? That is being applied to user. One of the things that it's going to do is that it's going to ask the table, ask this class, what's your name? And the class is going to say, oh, my name is user. And the entity is going to use the name of the class to look for, in Jdbc, is going to use Jdbc to look for a table called user. Okay, and then it's also going to ask the class, what are your fields and what are the data type of your fields, right? So it's going to look for a table called user that has fields ID, first name, last name, and so on. And that's all encapsulated in entity, right? And in the entity class, right? And we are applying that behavior to this user class. Okay. Let's see. Is there a question on the chat? It says, so in the table name users is calling the constructor of a table class? Yes. Yep. Yeah. You can pass parameters on how to configure all sorts of parameters. Yeah, it has a constructor and it takes as argument all these attributes, these name value pairs that you can say comma, 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 and you can pass all sorts of arguments, right? I mean, we're not going to get into aspect-oriented programming. We're just using the idea of aspect-oriented programming. We're not implementing any aspect-oriented classes, but certainly it's a very cool thing to do, right? And the idea for aspect-oriented programming is that what it allows you to do, what aspect-oriented programming allows you to do is use the user class just like any other class. Notice that we're not modifying the actual class. The class stays the same. So you could use this user class just like any other class. There's nothing weird about it. But if you use this user class in another context, like the ORM or JPA, right, it has a lot of behavior associated with it. Okay, so it allows you to keep the implementation of your original class, right, but append or add or augment your class with all sorts of behaviors that it's not implementing, right? Some parent class is implementing, and you're just augmenting that behavior to this with this class. It's a very, very powerful way of programming. Okay. Okay. All right. So yeah. So as I was saying, so by default, we are responsible for this unique identifier, but we know we have configured our table to use auto increment, right? So we need to tell our infrastructure saying, hey, I don't really want to be responsible for this unique identifier. I've already configured my table to be auto increment. So it's a generated value. This is a generated value, which I don't want to be held responsible for, right? The database is going to handle this, right? So we're going to override the default behavior and say that we don't want to be bothered with this. So we're going to say that this is a generated value. Now, a generated value, depending on which vendor, which database you're using, right? In MySQL, we do that using auto increment, right? In SQL Server, the keyword's different. I think it's identity. In Oracle is another way of doing it. They use what are called sequences, right? They use sequences. So sequence in Oracle is just basically a huge array of unique values, right? That start off with 1, 2, 3, and then it just goes on to trillions, right? Just one big numbers, right? And in Oracle, whenever you insert, right, instead of using auto increment, the ID, you can take the ID, the unique identifier from this sequence, right? And it says, well, you use the next number in the sequence to give me a unique identifier. So each database vendor has a different strategy on how these primary keys are set up. Okay, so we need to tell it what strategy is the do we want to use, right? What strategy? So for auto increment, right? For auto increment, the strategy is called identity, right? That's for auto increment in the ORM. The way auto increment is by identity. Generation type is identity. Okay. All right. That's it. That's all we need to do. Okay. We're done. We're done with the users. I mean, there's many other things we could do. You know, if, for instance, my field, you know, by default, for instance, first name automatically maps to first underscore name, for instance, right? It already does that for us, right? It understands, right, the different naming conventions. It understands, for instance, that underscore means that these are two words, right, separated by underscore, and to map it to the field here, it understands that Java uses camel casing, so it's capital N. So it automatically does the conversion for us, right? That, you know, underscore N matches with capital N here, right? That's automatically done. But say we had here, say we had called this instead just first, right? But this is called first name. Now the matching is completely bogus, right? Now it doesn't work at all, right? So you could override it. You could override it and say, hey, this field first, I'm going to give you a clue. It actually maps to the following column. You can say the actual column that this maps to, right? The name of the column, you know, is first underscore name, right? But we don't need it. We really don't need this because, right, it's using, right, the default naming convention, and the default naming convention works here, right? Capital N matches underscore N in MySQL, right? So this automatically happens already, but I could override the actual column that it maps to. Make sense? Okay. All right, excellent. We're done here. We're done. One more thing. We need an actual DAO. We need an actual DAO, right? And I know I said that we didn't have to write any DAO, but at least we need to have a generic DAO. Who implements this generic DAO, right? Well, there is indeed a generic DAO. Let's use it. Okay, so the way we use this generic DAO is as follows, right? So in the repository is where we're going to declare this generic DAO, and then we're going to use that generic DAO to implement our DAO. Right? So our DAO is going to be so simple, so trivial, right? Compared to our Jdbc DAO, ours is just going to be, you know, just a piece of cake, right? So, but it's going to be written in terms of this generic DAO, right? So let's create, and we're going to call this generic DAO, we're going to refer to them as repositories, right? Like data repository, okay? So we're going to create a Java class. It's actually not a class, it's an interface, and it's going to be called user repository. Okay, we're going to add it to our Git. Okay, and so I misspelled it. Let's refactor, rename it. Repository. There we go. Okay. So this is going to be our generic DAO. We don't want to implement it. We don't want to implement. That's why I noticed that it's an interface, right? It's not a class. So we're not going to implement it, right? Instead, we're going to inherit someone who already implemented this, right? We don't want to write our DAOs ever again. So we're going to, and what does a DAO do? Right? It implements a whole bunch of CRUD operations, right? You know, it's going to have a create function, right? An update, a delete, a find, right? All these functions are implemented in this CRUD DAO, right? So we're going to use a CRUD, you know, for create, read, update that already implements all the CRUD operations for us, repository, okay? And we need to configure it. It needs to know what is it that you want to CRUD, okay? In our Jdbc implementation, we were CRUDing users, right? We were creating users, we were deleting users, right? Updating users, we're finding users. So we need to configure it here. We need to tell it what is that we're CRUDing, because this can CRUD anything. It could CRUD a blog, you can CRUD a post, you can CRUD a user, right? You can CRUD a, you know, a recipe, right? A song, a playlist, whatever object you can think of, as long as you have a class and you have a corresponding table, this can do all the reading and writing and updating and deleting between the two. But we need to tell it what? Well, we want to CRUD a user. Okay. And the user is, what user did it bring in? Okay, so all right, that is the user. Yes, yeah, that is the user we want to. And that, notice that that user already tells. So notice that it already knows what table it's supposed to connect to, right? It has a class and it has a table. So that's all it needs. Well, actually, no, it needs one more thing. It needs to know the primary key. What is the primary key of this table, right? And what is the data type, right? So the data type is that it's integer. Here, it needs to be the class, not the primary, not the primitive data type. It needs to be the class, right? Integer. Right. All right, that's it. That's it. Now we can implement our trivial DAO, right, using our Crud repository. Right, let's do it. Okay, so let's go back to our ORM DAO, which you're going to implement. You're going to implement this from scratch. Well, almost from scratch. So notice here's create user. Create user. Instead of our create user, right? How do we implement our create user? Right. Well, we had to get a connection, right? Prepare a statement, populate our statements, right? From a user object, right? We need to execute, blah, 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 close the connection. We don't have to do any of that, right? We can say just .save. Let's use one that's easy. Let's do this one. Find all users. Let's do find all users. How do we implement find all users here? Right, we created an array. Right, we get the connection. We executed a find all users. We got a result set. We iterated over it. Right, we created a new instance of users. We read all the columns from the records. Right, created a new instance, populated an array, closed the connection. Well, let's see how we implement it here. The way to implement it here is that we're going to use the repository we just built. It's the user repository. There it is. And we just implement it and say we're going to return the repository dot, look at all these functions. See that? We have delete, find by ID. Ooh, look at this. Find all. That looks promising. That looks promising, right? Find all retrieves, presumably it's going to retrieve everything, right? And it's complaining because it returns an iterable and we're expecting a list. So we're just going to cast this. Just going to cast. There it is. So we're just casting to the right data type. Okay, that's it. One line of code, right? As opposed to, right, all this grabbing the connection, iterating, instantiating, blah, 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 closing the connection. Just one line of code. All right. Right. So let's try it out. Right. One more thing that we haven't talked about is, right, how does it know what database to use? Because over here we are, we're grabbing a connection from a database, right? From a username and password and all that. Where's all that? Right? Yeah, we skipped over that. We're configuring that right here in a file where we have all these properties where we are configuring all these things, right, outside, right, so that we don't have to encode it in our code, right? It's configured outside in a configuration file, right? There's the location of a URL, the username and password, okay? Right, so that's nice, right? We're not littering our code with any of this, and we can configure this separately, right? We can change the URL, we can change the vendor, we can change the login information outside without having to recompile our code, which is perfect. All right, so let's try it out. So how do we try that out? How do we test this? How do we test this? Well, we're going to test it using, we're going to try and test it by trying to hit this with a browser, see if we can get the data from a browser. So we're going to map this and say that this is a REST controller, meaning I'm going to make this class available on the web, right? So folks can can try and call and invoke these functions, right? These methods. They're going to try and invoke them with HTTP URLs that are going to hit these, right? So how do here I can configure that I'm going to listen for an incoming GET request that starts with ORM, right, and follows by, right, I can really, I can put anything I want here. So I could say find users. Okay. So I'm going to start a server who's going to listen for incoming HTTP requests here, and hopefully it'll retrieve data from our database. So let's see. Let's do that. Right. So the server is implemented right here, demo application. You can right click it and run it. So this is going to start a server listening at a particular port, which we can hit it right with a URL and then run this function. Okay, so starting up and says that it's listening. It's listening at port 8080. There it is. Okay, so let's do that. Let's go here in a separate tab and say localhost 8080 ORM find users, and that didn't work. What? Let's see what's got a 500 error. Null pointer. Request yada yada yada. Null pointer with root cause. Internal, yada, yada, yada. ORM DAO, line 21. Repository. Oh, yes, we forgot something. Sorry. Repository is null. So repository is null. Okay, this is null because I never initialized this. I never initialized it. Okay. So to initialize it, I can either try to instantiate it, but I can't instantiate it, right? Because the repository is it's an interface, so you cannot instantiate interfaces. Right? So basically, what we're going to do is that we're going to auto wire. So basically, I'm telling the infrastructure to create an instance of this, right? Really, it's an instance of what? It's really an instance. It's an instance of CRUD repository, really, right? Which is going to be instantiated. And then I'm just going to hold a reference to it, right? So let's try it out again. Let's restart the server. And hopefully this time I won't get that ugly error message. Okay, let's refresh. Let's see. There it is. We got the two records, right? Which are the two records that I had in there. See that? Okay. Right. Let's play around. So how nice is this, right? I was able to, in a single line of code, right? Implement what it would have taken me, several lines of code here, right? So a lot of magic is happening behind the scenes, right? So that a lot of plumbing and a lot of boilerplate code is being written for me, right? Notice that when we go there, when I hit that URL, notice what's happening behind the scenes. My ORM is writing the select statements for me. It's sending these select statements to the server, right? With from users, and then populating all these values. It's retrieving all the select statements, right? So that I don't have to write the SQL. It's writing the SQL for me. It's writing the SQL for me. Now, I might not like the SQL that the ORM is using, right? I might say, oh, that's really ugly SQL, right? So I could override. I can override and say, don't use this find all, right? I have a better implementation, okay? So instead of this implementation, use the following implementation, right? I can say, go to the repository and say, you know what? Instead of using your default find all implementation, instead of using this find all, I want to have my own implementation that uses my SQL, right? Because maybe I feel that I can write better SQL than the ORM. Okay, so for instance, I might say, use the following query instead. Use the following query, right? That has the following string, select star from users, right? Maybe I think I can write better SQL than you, right? And this is native. So this is native verbatim. I want you to use this verbatim, this select statement verbatim. So don't try to pre it up, right? I know what I'm doing. This is the SQL statement I want you to use. And since I don't really want to use SQL, I'm going to wrap this low-level query. I'm going to wrap it inside of a function, right, that allows me to treat this, right, at a high level object-oriented level, right? I'm going to wrap it inside of a public function that is going to parse the result set automatically. It's going to parse that and it's going to convert it into a list of users. And I'm going to call it, get all users. I can call it whatever I want. And notice that I'm not implementing it. I'm not iterating over the result set. I'm not trying to instantiate one at a time and creating user objects, right, and populating an array list, right, and then closing the connections. I'm not doing any of that. Okay. Instead, right, I'm giving you the query, and I'm telling you I want you to try and convert whatever comes back. Try to convert it into an array of users. Okay. Right. So when I come back here, I can now rewrite this. I can rewrite this with my brand new repository dot, get all users. See that? All right, let's try it out. Let's restart. And so now the ORM is going to use my SQL instead of using, it's going to use my SQL instead of using its default SQL. Okay, so it's restarting. Let's try it out. Okay, notice that it works just the same, right? And notice that it's using my SQL statement. See that? It's using my SQL statement instead of its own SQL statement, right? All right, let's do one more. How about this one over here? Find a user by ID. Again, there's a default implementation, right? There's a default implementation that is based on the repository dot, there's find by ID. Look at that, right? There's a generic version of this that if you give it the ID, it'll retrieve the object. But it's going to retrieve it inside of another object, right? That allows me to test whether the results here is null, right? Whether there was no results that came back from the server, right? So I can unwrap that and actually get the actual act in there and the result. I know there's an object with that ID, presumably, right? And I can unwrap it, and I know there's a user object in there, right? So let's try that. Let's map this to, get mapping, something like ORM find user, and then I'm going to pass you as part of the path. At the end of the path, I'm going to pass you an ID, a user ID. Okay, notice the curly bracket says that there's a placeholder there. I'm going to try to parse that, right, and pass it as a parameter to my find method here, right, so that I can pass it to my find by ID. Okay, so I'm going to parse it the way we parse the path. We can parse it with path variable. We can parse it with the name of the field is called user ID. Right, we're going to parse it, and then we're going to pass it as a parameter, right, which then is going to be used by find by ID. Right, so let's try that. Let's run it, see if this blows up. Let's see what users do we have. We have user 17. Okay, so presumably we can say find user /17, and notice that indeed it returns Tom, or 18 it returns Catherine. See that? By ID, I can retrieve a single object. Okay. All right, let's do one more. How about I want to delete a user? Okay. So for instance, let's see what we have by default. We have repository dot. Let's see. Oh, look at that. It has delete by ID. So if I can pass the user ID. Oops. Okay. Here again, I could override the default delete that the ORM gives me, but I'm not going to bother, right? The default implementation for the delete is good enough, right? So I'm going to just keep that. I'm not going to override it, right? I can then return maybe a 1 here, meaning I was successful, right? And then I'm going to run it, with a get request and say, ORM, delete user. I'm going to pass in the ID at the end of the path, and we're going to parse that. We're going to parse the path with a path variable and the name of the path variable is called ID. So this, right, this is that, right? I'm going to parse that out. I'm going to pass it as a parameter to the function so that it can be passed down to the delete. Okay, all right, so let's try that. Let's restart the server. Okay, so let's see. So we still have 2 users. Okay, let's remove one of them. So let's say, so we have a delete user, and then the ID is, say, 17. Let me spell it. Orm delete. Orm delete user. Oh, users. Let me spell it. Users 17. Okay, there it is. 1. So retrieve all the users. Notice that Tom is no longer there. See that? Okay, let's do one more. Let's do one more. How about creating a new user? Let's create a new user. And I'm going to pass here several strings, one for the first name, right? One for the last name, one for the username, and one for the password. Okay, I'm going to create a brand new user, right? So we'll say user, new user. And I believe this, yeah, we're going to pass the first name, we're going to pass the last name, we're going to pass the username, the password, and null for, I think this constructor, yeah, takes first name, last name, username, password, and profile picture. So there we go. We have we're passing all that. So once we have the user instantiated, right? Once we have this user instantiated, we can use the repository. Has a function called save. See that? That's save. Save does an insert. Does an insert into the database, right? With we're passing, mapping all the fields to the correct fields, right? And then it returns the actual object that was inserted, along with the primary key that was created when the data was inserted in the database using auto increment and all. Okay, all right. So let's restart. Oh wait, no, we have to map this to something, right? We're going to map it and say, get mapping. So this will be something like orm create user, and we're going to pass in first name, last name, username, and maybe the password. And then we're going to parse this, right, as path variables with first name. Let's paste it in here, all these. This would be first name, this would be the last name, this would be the username, and this would be the password, right? And then we're going to use it to insert it into a database, right? I mean, compare this to the way we did create here, right? The way we did create in the Jdbc version, right? We had to get a connection, right? Prepare the statement, and then populate each one of the elements of the statement, right? Then execute it, and then close the connection. Over here, it's just basically 2 lines of code, right? So let's try it out. Let's run it. And let's try it out. So let's see what users do we have. Oops. Let's find all the users. Right now, we only have Catherine. Let's create a new user. We'll say create user. So there we go. We have somebody already ready, Walter Williams. So let's do that. There it is. So it comes back with Walter Williams. We have created Walter Williams with ID 19, right? If we go to a database and we do a request, notice that indeed we did insert Walter Williams. Right? If we go back and we refresh and get all the users, notice that Walter Williams is indeed inserted in there. Okay. All right, so now if you contrast, right, our implementation of this ORM, right, compared to the Jdbc implementation, right, it's clear that the ORM implementation is so much more easier to work with right? Nevertheless, JDBC has its place, right? Obviously, somebody had to write this repository. The repository is written underneath using JDBC, obviously, right? So depends where you are in the abstraction layer in your project. If you are working, low level, creating libraries that help that enable other folks to be more productive, then certainly you have to go to the JDBC route, right? Where you are way down at the abstraction layer, or if you are higher in the food chain, right, and you're using these libraries, then then the ORM is for you. So again, it depends where you are and what is that you're trying to write. Do you need the full power, right, and flexibility and full control of your database? Then you have to go JDBC route. If instead, right, this is a very well-defined schema, right, it has been around for years, and we just need to interact with it, right, and we don't need any fancy, right, interaction, then definitely the ORM route is better. Okay. So anyway, so there it is. So this is we're going to be chatting some more about ORM. There's much more about ORM that that's very, very advanced. We'll play around with it. It's not part of the assignment because it's fairly advanced. We'll touch on it. We'll demonstrate it, right? And obviously you're welcome and encouraged to use it, perhaps for your projects, right? But we're not gonna get into some of that in the assignment anyway, right? So yeah, we'll revisit many of these topics in the upcoming weeks. All right. All right, any questions? All right, so if no questions, then that's all I have for you today. Thank you, everyone.
Thank you, Professor. Have a nice day.
Take care. Take care. Bye.